The first problem is starting at the time of 0 seconds, an object moves along a straight line with the velocity of 6 minus 2t. We need to calculate the displacement and distance traveled by the object at a time of 5 seconds. As shown in the screen, the formula is 6 minus 2t, and then we have the seconds that we want to take out. Then we antiderivate to get to the result of 6t minus 2t plus c, and with that result we just substitute the times of 0 and 5 to get two answers, and with those two answers then we can make our integral. And the first thing to do is to take out the value of t, which in this case t equals 3 seconds. With that we just need to substitute so that we could know if any of those results need another sign, and we got to the conclusion that when x is bigger than 3 it will need a sign of minus. And then with that we just make our new integrals, and those are the ones that we got. Then the only thing left to do is to substitute, and we got to the conclusion that the displacement is 5 meters and the distance traveled are 13 meters.
Okay, so in order to solve letter A, we need to know that integrating acceleration we get velocity, and that's what it tells us to do in letter A. So we need to integrate acceleration, which will be equal to velocity. So we integrate the expression of acceleration, which is 60 minus 18, and this will be equal to 60 squared over 2 minus 18t plus c. And this simplified is 3t squared minus 18t plus c. So now the problem tells us that time is 0 when velocity is equal to 24. So we need to substitute that in order to get the value of c. So velocity is equal to 24 and time is 0. We substitute that and we get that 24 is equal to c. So now we have the answer of letter A, which is 3t squared minus 18t plus 24. There. Now on letter B we need to do the same as letter A, but we need to find the position. So we remember this, that integrating velocity we get position. So we need to integrate the expression of velocity. In order to get position, we integrate, we simplify, and then we substitute what the problem tells us, that the position is 20 when time is 1. So we substitute those values and we get that 4 is equal to c. So now we have our expression, which is t cubic minus 9t squared plus 24t plus 4. So finally, we need to find the total distance traveled by the particle from 1 to 3. So in order to find the total distance, we need to use the expression of velocity. So we need to integrate this expression and arrange it from 1 to 3. So first of all, we need to find the values of t. So we factorize. It tells us that t is equal to 4 and t is equal to 2. But we need to use 2 because we can't not use 4 because it's out of our range. Now we need to know our ranges. We need to know values that are less than 2 and values that are greater than 2. So we need to find which one we need to put the minus sign. And to find that, we need to substitute values. So values that are less than 2 are 1. So we substitute and we get that it's equal to 9. And then values that are greater than 2, we substitute and it's 3. And this gives us a result of minus 3. So because this is negative, we need to put a minus sign here. So the next step is to integrate these two. So from 1 to 2 and from 2 to 3. but this one is negative. And this negative sign affects the others, okay? So we integrate that. It gives us 3t cubic over 3 minus 18t squared over 2 plus 24t plus c. And on the other side, it gives us the same but with other signs, and we simplified. After we simplify, we need to know the values of f of b, f of a, and the other f of a and f of b. So we substitute f of b, we get that it is equal to 20 plus c, and we substitute 1, which is 16 plus c. So from this we get that f of b minus f of a is equal to 4. We do it the same on the other side, and we get that f of b minus f of a is equal to 2. So this adding these values, it gives us that the total distance is equal to 6.